When we do statistical testing, it's vital that we examine our data to make sure that our data meet the assumptions for the test that we want to use to analyze. One assumption of most parametric tests is that the data do not contain outliers. We're going to learn what is an outlier and what problems do outliers cause. An outlier is an unusually high or unusually low score in our data set. This outlier lies far out from other scores. It does not fit the other data. These are extreme observations, and as such, they are very rare. How would we spot an outlier if one existed in our data set? The simplest way is to look at a histogram. This is a histogram of ages of workers in a specific workplace setting. Now we can see that the youngest age is around 18 and the oldest or next to oldest age is somewhere in the mid-60s. We see that there are more people in the younger ages from, let's say, 18 to 38, and as they get older there are fewer people in this workforce. This is about what we would expect in a workforce such as this one that is being measured, which I'm not telling you specifically what workforce that is. You will see in this histogram an outlier, someone whose score is older than 88. It will probably come as no surprise that I know exactly who this person is, and that is a problem. Outliers can identify individuals in a data set. So when I look at these numbers, I find this person who is 88. I can identify that person in my data set, meaning they are no longer de-identified. And that respect of privacy is very important in data collection. This is just one of the problems that can be caused by outliers. What are the causes of outliers? There are many, and those causes will differ depending upon the type of data. Let me start most simply and build up to most complex. Let's start with a single item, one variable in your data set. For a single item like biometrics or demographics, for example, the age variable that we just examined, we can have legitimate outliers. That individual who is over 80 years old is a real person who really works at this organization. That person is a legitimate outlier on the variable of age. That doesn't mean that because the outlier is legitimate, it won't cause problems. In fact, outliers will still cause problems regardless of their cause. However, what we choose to do about those outliers will depend upon whether those outliers truly do belong in the data set or not. A second example of a single item would be a Likert scale that is limited by answer options, such as 1 being disagree very much, up to 6, which means agree very much. With a single item Likert scale, we will not have outliers because each individual is limited only by the answer choices from 1 to 6. What if we had an answer choice that was greater than 6? That would probably be a data entry error, and we're going to talk about how we would fix those. Outliers can also occur on a single variable, and these are called univariate outliers. This is an individual who is at the extreme high or low on a single scale. But in order to have a univariate outlier, we would need to have a subscale with multiple items. Now let me explain best practices when doing research. You should, if you can possibly avoid it, not use a single item to measure a construct. The best way to measure a construct, such as job satisfaction, is to ask a question about job satisfaction in multiple ways. And then we're going to take each of those items, which are measuring something slightly different about job satisfaction. We'll combine them add up the scores, divide by the total number of items, giving us an average score on that subscale. Let's look at an example. This is a satisfaction with pay subscale. We see that there are 4 questions, each of which have a 1 to 6 answer option. The first question, I feel I am being paid a fair amount for the work that I do. The second, raises are too few and far between. This question is the opposite direction of the first question, meaning that we would reverse score it before we added up the values and divided by 4. The third question, I feel unappreciated by the organization when I think about what they pay me. Again, that would be reverse scored. And the fourth question, I feel satisfied with my chances for salary increases. We would take each individual score on these 4 items, add them up, divide by 4 to get a score for that individual. Let's look at what might happen. We have employee A who answered 3, 4, 4, and 3 on each of these 4 measures of pay satisfaction, giving a total score of 3.5. We also have employee B who answered 1 on each of those 4 measures of pay satisfaction, a total score of 1. This would be a univariate outlier. This person is really dissatisfied with the pay. It may be legitimate that this person truly feels that way, but we want to examine our data set to make sure this person is not an outlier. If almost everyone is roughly generally satisfied with the pay, and you have one individual who just hates the job and hates the pay, that person is not like most people in the data set. And therefore, we would need to make some decisions about what to do with that outlier. Multivariate outliers are extreme scores on multiple scales. Therefore, to have a multivariate outlier in your data set would require multiple subscales. We can test for multivariate outliers using something called a Mahalanobis test. I'm not going to show you how to do a Mahalanobis test in this video, but I do have others that explain the procedure. Let's take a look at what a multivariate outlier would look like in our data set. Again, we have employee A and employee B. But now, instead of simply considering the satisfaction with pay, we're considering multiple scales that measure the construct of job satisfaction, such as satisfaction with pay, satisfaction with promotion, supervision, fringe benefits, contingent rewards, operating conditions, co-workers, the nature of the work, and communication. By combining all of the scores on all of the subscales, we have a measure of total satisfaction, or global job satisfaction. What we can clearly see is that employee A is more typical of what we find in a job satisfaction survey. This person likes certain aspects of the job more than others. This person's highest score was satisfaction with coworkers, followed by nature of the work and supervision. So this is someone who likes his or her coworkers, likes the boss, likes the job, but when we look at other subscales, we find that this person is dissatisfied with the pay and the contingent rewards. So for instance, maybe the health insurance plan is lacking and the pay is low, but this person really loves the work that he or she is doing. What we are seeing here is a picture of this person's level of job satisfaction, both in a more granular way by looking at the subscales, and we see that person's overall job satisfaction rating. But now let's look at employee B. This employee hates everything. This employee chose the most extreme negative response on every single item, on every single subscale. This is a multivariate outlier. Those are some of the types of outliers, but what problems do outliers cause? Let me illustrate this with a few data sets. In this example, I've created dataset X, which contains values including an outlier. It's the 20, which I've represented in orange. I have Windsorized that outlier in dataset X1. I have brought that outlier of 20 down to the next most reasonable value, which is a 9. I also have variable Y, which I could use for measuring correlation. Let's take a look at how the outlier has affected each of these variables. Number one, having an outlier will distort the mean in the direction of the outlier. The data set with an outlier has a mean of 6.44, but once I fixed it, the mean was brought down to a more reasonable 5.22. Second, the outlier will inflate the standard deviation. Notice that with an outlier, the standard deviation is a 5.64. After fixing the outlier, the variability was brought down to a more reasonable 2.82. Many times when we're doing statistical research, we want to know something about a population, but we don't have access to the full population data. Therefore, we select a sample and we take what we learned from our sample and apply it back to the population. Remember that a sample creates a statistic, whereas the population has a parameter. When we use a sample statistic to estimate a population parameter and our data set has outliers, then the outlier will bias our population parameter estimates. What we learn from the sample does not apply to the true population. The outlier will distort the normality of the distribution, dragging the distribution out in the direction of the outlier. And finally, confidentiality. As we saw in the example with ages, when there is an outlier, that may actually identify someone in the data set. And that is always a problem, because one promise that we make to our participants is to protect their confidentiality. We should never have information in the data set that can identify one individual. Or if we do, we want to remove that data or hide it in some way, especially before we share that data set with someone else. Always protect the confidentiality of your participants in scientific research. Now you know the kinds of problems that can be caused by univariate outliers. Next, let's see what can happen when we have bivariate outliers, outliers on two variables. And for this, we're going to look at a scatter plot. In this simple scatter plot, with no outliers, we see a moderate positive correlation of an R equals 0.36. But now I'm going to add an outlier on the x-axis that is very low on the y-axis. And what we see is that outlier in the lower right quadrant completely removes the correlation. The correlation is dropped to 0. If I have an outlier that is low on the x value and high on the y value, that outlier can actually reverse the direction of the correlation. Now we have a correlation of a negative 0.09. An outlier that is high on both x and y scores could artificially strengthen the correlation, making it seem stronger and more robust than it actually is. Bivariate outliers attenuate correlation coefficients, and therefore we need to know what to do about outliers when we find them in our data set.